All right, good morning, everybody. This is Jamel from the H2O Hustle podcast and YouTube channel, and I'm coming to you today to launch a new podcast series that I wanted to do on steam operations because I just recently went through a career shift where I was a drinking water operator and also had wastewater experience with that. So in the municipality of Bargersville Utilities, I uh, had almost 5 years of experience and 5 years of working experience at Bargersville doing drinking water operations and was able to learn the core things of that and serve the community of Bargersville in that time. And then I had left there to accept a position at a bigger utility where I live and closer to where I live, and pretty much um, accepted the role as a utility shift operator and to assume the role of a pretty much boiler operator. So doing things, doing water treatment on boilers and um, different types of um, maintenance and some other things on boilers. And I just thought that I would start a new podcast series on that because I'm learning about what it takes to be a boiler operator. I'm learning about how to get licensed and is it important or is it not important, like all those things and all those different parameters around boiler operations. So I just thought I would start a new podcast series to help people that maybe want to get into this type of industry and learn about it. And for those that are just curious, just to know, like, what does a boiler do? Like, what's the history about it? And like, all those things. And I'm gonna say this from the beginning that I am not an expert in this, but I am learning this on my own as I go. But I definitely wanted to, you know, put this out there so that others can know and learn as well. So as much as you're learning, I'm learning too. So, but today I wanted to create a podcast show um, talking about and discussing about the history of steam boilers, like a history lesson, and it might bore some of you to tears, but I think that's the best way to start is to understand how boilers came about and what um, caused this to be a thing and to be a vital source of energy or power or things that we do in our everyday lives or what we use for our everyday lives. This type of thing. It covers a lot of things that we do and we don't even realize it. But anyway, to start this thing off, we got to understand that we got to go way, way back, almost nearly 2,000 years ago, around the first century AD. A person by the name of Hero of Alexandria developed a device known as a aeolipile. If I could say that right, is aeolipile or aeolipile. I may be saying that wrong. I may be butchering it wrong, but anyway, it consisted of a hollow sphere that rotated when steam escaped through bent nozzles. And even though that wasn't it wasn't an actual boiler or an engine or anything like that. It just demonstrated the principle of how steam worked, and that when the heated water produces steam, and then expanding steam can create motion. So that's what it showed us back in those days in the Roman days over 2,000 years ago that steam, the principles of how steam works. And so that was the beginning stages of understanding, a history of steam boilers. We got to understand how steam came about. And it came about in that kind of way. And then, those things back in the Roman times, they used them as toys, so to speak. They wasn't really even for industrial use. They wasn't for any kind of production or anything like that. It was just mainly as just like a thing to show off. So like people back in the Roman days, like you'd come over their house or you'd come to their palace or whatever it was that they had, and they had these types of things, and they would just show it off as just like an entertainment piece. And so that's how those things came about, and the steam and the understanding of steam. But then we continue to go on, and as time went on, then we get into the birth of practical steam power. And when we look at that, we're looking at the 16 to 1700s, where this is more like in the industrial, or getting close to the industrial revolution. But this is more like when a lot of people started to dabble into learning how to make steam and create steam to make it powerful, and make it as a power source, if as I should say. But the mining industry and everything in Europe, and especially Great Britain, um, you know that they had water flooding underground mines, and this created the need for machines capable of pumping large quantities of water. And in 1698, Thomas Savery, or it could be pronounced Savory, he patented an early steam powered pump known as the miner's friend. So this steam pump, it was used to it was used steam pressure to condensation to move water. So, however, the system had limitations, including low efficiency and the dangers associated with steam pressure. So we have Thomas Savery, showing us how to use steam in a pump form to remove water and all those things out of mines. And so we have him coming on the scene doing something and showing us that it's important for us to learn how these steam was used back then. In 1712, Thomas Newcomen, he developed the atmospheric steam engine, and this was used when the steam was condensed and in vacuum form, allowing atmospheric pressure to move a piston. Newcomen's engine became widely used for pumping water from mines. So these two people, when these miners back in the day would mine and do all these things, they were using their innovative minds to come together at different spaces of time to make these pumps for pumping water from mines. And it shows that steam was very important back then, and that we're seeing the progression of how steam is used, and to become eventually boilers, and how boilers are used. So, the boiler at that time was primarily used as a simple vessel to use to boil water. So it wasn't to produce energy or to do anything like that in an industrial setting. It was just used to boil water. But things are, becoming more and more advanced by the years, so that we see the progression of everything and how it's coming about. But compared with the modern standards, these early boilers had limited pressure control, primitive construction and a few safety devices. So then we move, during the late 1700s, and a guy by the name of James Watt, during the late 1700s, he came in and he Watt, he recognized that Newcomen engine wasted enormous amounts of energy. So Newcomen made the his engine for to remove water from mines and all those things, but what it wasn't efficient enough. And then James Watt came, and then um, what he did was he developed of the separate condenser. He made a separate condenser, dramatically improved steam engine efficiency. So James Watt just kind of tweaked it a little bit and made it a little better so that, it wasn't wasting all of that energy, because it's to harness it and to make it more efficient. So that now this was the turning point of steam. It just wasn't no longer useful for pumping water out of mines, but now steam engines began powering these factories, the textile mills, manufacturing equipment, transportation, ships, and industrial machinery. So this is when things started to become good, you know, and become more beneficial for what we call the Industrial Revolution. As the demands for steam power increased, the boiler became one of the most important pieces of equipment of the Industrial Revolution. So we see that in the late 1700s, and James Watt was the catalyst that turned this around from not just pumping water out of mines, but to make this to where it can begin powering these factories and these mills and manufacturing equipment and all this stuff that they were using for the Industrial Revolution. So the Industrial Revolution comes during the late 1700s and the early 1800s, and then these engineers, they begin to experiment with higher steam pressures. Richard Trevithick was one of the major pioneers of high pressure steam. Higher pressure steam allowed engines to become smaller, more powerful, more efficient, and more suitable for transportation. This development helped make steam locomotives and steam powered transportation practical. So more so for like the train and all those things like the locomotives and everything and that. So Richard Trevithick, he was the catalyst for that, and that helped out the Industrial Revolution, because then you got all these factories and all these mills, and then the locomotives, and then they can transport goods and materials and things. Things are starting to come together. So as we look back, you looking at it as from the Roman times, it was just something to be enamored with, or for entertainment, to see like, wow, we can, play with steam. And then now it's coming to, the early 1800s, and it's like, well, now we can use this for, you know, um, factories and an industrial revolution and businesses and stuff and everything that we know, or we're going to come to know in our modern time. But, you know, but with all of this happening, and this will allude to what I need to do in my next podcast show, or study up on that and let you know. But with all of this new advancement in their technology and everything that they were doing back then with steam and steam engines and high pressure steam, is that these early boilers were often built with inconsistent materials, and they were poor welding or fabrication methods and limited pressure instrumentation, and all this, inadequate stuff. And what it did was it created these boiler explosions, which there's a lot of those that hurt a lot of people back in those days because they had all this high pressure steam, but they didn't know how to probably you know um vent it off right or do all these other things, or the way the boiler was constructed was very poor, or they didn't have water chemistry to a good degree back then. So all of this stuff, it was just uh a a grouping together of all of this, and then it made these boilers explode, and that's not good for people, and that's not good for you know business back then. So if a boiler was operated with low water, metal surfaces could become overheated. So, and as we know today, like when you have low water and there's not a lot of water in the boiler, and those metal surfaces become very heated, then these things, it can explode, because when you put especially cold water in a boiler, it will explode, and all these things, and from the scale build up to you know plug up the tubes, and all those kind of things, it hurts the efficiency of a boiler. But these explosions became a major public safety problem, and all those things, and that's why like I said, in one of the newer shows that I do, the next show probably that I do on boiler, you know, like boiler, just boiler things, and like so the history of the reason why the history of boiler safety remains such a responsibility for today's operators is because of those explosions. But when we look at the codes for boilers and how to get licensed and all that stuff, we're going to talk about this because it's important for us to know that that's the reason why that we have these codes and all this stuff nowadays in order to operate a boiler, because of all of those explosions. So one of the things that we understand is that, so we're going from the industrial revolution, where now they're starting to become boilers, and they're not efficient boilers. But then as time went on, one of the most important early boiler designs was the fire tube boiler. And in a fire tube boiler, you got hot combustion gases travel through tubes surrounded by water. That's what a fire tube boiler is. And the heat from the combustion transfers through the tube walls into the surrounding water, producing steam. Fire tube boilers, they became widely used in steam locomotives, so in trains, in factories, in heating systems, ships, and small industrial factories. This is very important. So we see a lot of these fire tube boilers in existence then, and they were widely used in those applications. And one of them is the designs that's widely known as a Scotch Marine boiler. It became one of the most recognized fire tube designs, and it was originally developed for marine applications. It was used a large cylindrical shell containing furnaces and multiple fire tubes. Um, they were valued, these fire tube boilers, because they were simple, they were relatively simple to operate and make and all those things, and construct. They were durable, they were reliable, easier to operate, well suited for lower to moderate pressure applications. So when you got a low pressure boiler, you're looking more for a fire tube boiler. And so that was like one of the first major um, boiler designs that we know today. So then we go from fire tube boilers, and now we're going to water tube boilers. And water tube boilers, you know, as industries, when they demanded higher pressures and greater steam productions, these fire tube boilers, the ones we just talked about, they were limited because they're for lower pressure and lower application to moderate pressure application. But a water tube boiler is for higher pressures and greater steam production, and we see that in these industrial boilers, in these big industrial factories, and that's why the water tube boiler was created. And in a water tube boiler, we have water and steam. They flow inside the tubes while hot combustion gases flow around on the outside of the tubes. So, in a water tube boiler, the water and steam, it flows inside the tubes, and then the combustion gases and the fuel and everything forms on the outside. Whereas in a fire tube boiler, the hot combustion gases flow through the tubes and it's surrounded by the water. So that's how we can differentiate between the two of a water tube boiler and a fire tube boiler. And so, when you look at the water tube boilers, the design for those, they were to operate at higher pressures, higher temperatures, greater steam capacities, and faster steam generation rates. And so, when we look at those, when you look at an important early water tube design, they included Babcock and Wilcox boilers, which are really known boilers, Stirling boilers, D-type boilers, O-type boilers, and A-type boilers. And water tube technology became the foundation for many modern utility and industrial steam plants. Um, so a lot of these plants that you see power plants, powerhouses that's doing things with this type of boiler technology, the modern utility industry steam plants are water tube boilers. The plant that I work in is a water tube boiler plant, and then the other satellite plants that we have for the hospital and the college campus, they're fire tube boilers. So that application over there is fire tube, but the plant that I primarily work in is a water tube technology boiler plant. And so we see that with water tube and fire tube, we see the difference between those two. So during the late 18 and 1900s, steam technology entered another major era, and that's the electric power generation era. So now, instead of these boilers are just doing, steam operations for factories and, locomotives and all these other things. Now they're going to take these boilers and this power and this energy source, and now it's going to be used for electric power generation. So instead of steam, you know, driving to reciprocating engines, and high pressure steam can now drive these steam turbines. And a basic steam power cycle is this. So you have fuel, which is fueling the boiler, which the boiler is producing high pressure steam. Then the steam goes to the steam turbine, then to the generator, and then it generates electricity. So that's the progression, and how steam boilers can produce electric power generation. So the steam exhaust from the steam turbine, it could be condensed back into the water. It can be treated, pumped back toward the boiler, or reused in the steam cycle. So that's how the exhaust steam can be used in a in this type of application. And this dramatically expanded the role of the boiler. The boiler at this point, it was no longer used as a vessel for boiling water. Now it's being used to be a steam generator capable of converting the chemical energy of fuel into thermal energy. So that's what is majorly uh, becoming in the 1900s, is now it's doing electricity and thermal energy and power for heating and electrical and all that stuff. And when we look at all of that, we see that throughout the 20th century, now we're coming into the last century that we were just in, that boiler technology became increasingly advanced. So these boilers began having automatic combustion controls and feed water control systems, flame safeguards, burner management systems, safety interlocks, continuous water level monitoring. The chemical feed systems, became an important um, thing for the boilers. The economizers, superheaters, air preheaters, scoop blowers, deaerators, condensate recovery systems, and emissions control. So all these things, which, like I said, I want to get deeper and deeper in learning into all of this, but these things are what developed in the modern boiler systems and how boiler systems are operated. So, operators, things it's becoming much more technical. So the operator just doesn't simply fire the boiler. We're becoming more responsible for monitoring all the things that's involved in that's interconnected in the system. So we're monitoring the fuel and how much fuel is in the boiler and the heaters and stuff, and the air and the water. The water is very important. That's something that we have to realize and recognize, that water treatment is a vital source of operating a boiler. If your water is off and your water quality is not good, then the boiler efficiency is gonna hurt, because you're gonna lose money with fuel, you're gonna lose money with repairs and all this other stuff. And like I said earlier, that these boilers can become they can create explosions when your treatment and other stuff is bad. But uh, you know, these boiler operators, as we're called, we're responsible for chemistry and steam and pressure and temperature, all these other things, environmental compliance and a whole bunch of other stuff. And, it's growing and growing of what we do. But when we talk about the fuels, you know, there was different fuels that we could use throughout history. And sometimes, back in the old days, they would use wood as a source of fuel because it was readily available. All the trees and things that they could cut down and break down and use as fuel. They used that. Coal was a big one. Coal, especially during the Industrial Revolution. Coal became the dominant boiler fuel. Coal had a higher energy density than wood and supported the growth of the railroad industry, the factories, the power plants, and the steamships. Coal was very, very big and very important to use. And the plant that I work at, they had been a coal facility for many, many, many years. And then in 2015, they went from coal to natural gas. So yeah, so coal was a very big vital source for these power plants and boiler plants and everything. Oil was used in these applications as well. Oil fire boilers became common because liquid fuel could be pumped, atomized, controlled more precisely, burned with less manual fuel handling. And then, like I said, I was talking about natural gas. Natural gas became popular because cleaner combustion, easier fuel control, reduced ash production, and fast burner response. And now we have modern energy sources where modern steam generation can be used from a biomass, waste derived fuels, nuclear heat, waste heat, electricity, renewable thermal energy, um, and you can transfer heat energy into water to produce steam safely, efficiently, and reliably. We have a renewable uh, thermal energy source, so there's another plant that's that breaks down waste and methane, and then they pump that steam from the waste plant to us so we can use it as a renewable energy source to produce steam for all of our customers that we do. We have 250 customers through the downtown area that we service and that we produce steam for. And like I said, this renewable energy source that we get steam pumped from. A good, I think, I don't know if I got the numbers right, but I think a good, at least half of the steam production for our 250 customers comes from our main plant where I work at, and then the renewable energy source produces the other half or the other like 25 to 30% of it or whatever, and then it's pumped to us, and then we pump that to our customers, so produce steam for them. So, but yeah, these are the things when we talk about fuel that's very important. There's different types of fuel sources, but a lot of people probably nowadays, or like you said, the modern energy sources are trying to do that to get away from the coal and the wood and all that type of stuff, or even natural gas, or using like hybrid um things of it to where they'll use some gas but other renewable energy sources that'll help. So we're going back to talking about boiler, and we're going to talk about the growing importance of boiler water treatment. And like I said, this is very important because water quality is critical. So early boiler operators didn't have the sophisticated understanding of water chemistry that exists today. So we know that poor water quality can cause scale, which that's hardness, minerals that can deposit on heat transfer surfaces. Scale is an insulator, so it's going to insulate the tubes that's in these boilers, and it's going to cause the metal to overheat, and when it does, it causes lack of efficiency in boilers and become so dangerous that these boilers can explode. Then you got corrosion. The oxygen that's in the steam system and everything. It can cause pitting on certain types of inside the boiler, and that's not good. And you want your dissolved oxygen, carbon dioxide, the improper pH, and these other conditions. They can attack the boiler system metal, and you don't want corrosion in your system because nothing's going to work right. Then you got the carryover from the boiler water contaminants can be carried into the steam system. You want the steam to be as pure as possible when it's going out and being used in the different industries that's using it and everything. You don't want bad steam because then it's not good for the customers. Like I said, some of these hospitals and other places where like surgeons they will use steam to clean their their medical equipment that they use or these things types of tools that they use in surgery in surgical rooms and all that stuff. They want the steam to be pure. So that's definitely something that we have to understand. Foaming and priming, improper boiler water conditions can cause water droplets and contaminants to leave the boiler with the steam. And we don't want that to happen. We don't want the contaminants to leave with the steam and all that. We want it to have, a separation and clean, pure steam going out. Um, you know, the modern boiler plants, they use sophisticated water treatment systems, and what we use, now in these day and age, clarification, filtration, lime soda ash softening, zeolite softening, reverse osmosis, demineralization, deaeration, oxygen scavengers, phosphate treatment, pH adjustment, and blowdown control. And at the plant I work at, a good majority of this is used. We do lime soda ash softening, zeolite softening, deaeration, oxygen scavengers. We do pH adjustment or pH control, blowdown control, clarification, filtration, all of those things we use in our water treatment at the plant that I work at. So, um, but for somebody with water treatment experience, like how I had in drinking water, it kind of translates over to what I'm doing. So I kind of understand the key that hey, the water treatment is very very important to have that because you want your boilers to work right and everybody to be safe and the customers happy and then everybody's happy. So we're definitely going to have to hone in on our water treatment skills as boiler operators and all of that. Um, so then we have these things to where um, there's different codes. And like I said, I'm probably going to hone in more on this on the next show. Um, look into more of this, but the history of boiler operation includes many catastrophic failures. And when we look at that, um, you know, these boiler explosions and all these things, there was the creation of a standardized boiler construction and inspection requirements, and the American Association or Society of Mechanical Engineers, or the ASME, they developed the boiler and pressure vessel code. And when they did all of this, they, want us to understand that now we have safety valves and low water cutoffs and flame scanners and fuel shutoff valves and pressure controls and, so many other things, or license and train operators. Like all of this is for us to help us to be safe and to know how to operate a boiler and to do all of those things. But I just want to give a brief, um, you know, thing on that, just to talk about that because it's important for us to know the codes and to know all of these things, uh, to be able to efficiently operate boilers is very important. So, but the modern boiler operator, you know, is a part mechanic, is a part water treatment technician, a part process operator, and a part troubleshooter. And we will monitor steam pressure, steam temperature, water level, feed water flow, fuel flow, combustion air, flue gas conditions, the water chemistry, the pH, the conductivity, the hardness, chlorides and dissolved solids, alkalinity, sulfites, all those types of things. And, an operator, we look at pumps and fans and burners and valves and water treatment equipment, steam distribution equipment, condensate systems. So we have all those things that we have to look at. So it, it went from people, wanting to, back in the Roman days, looking at this as something to, be entertained by, to now we're using it to help people and to help lives and to know that this world runs on steam. A lot of people don't realize it, but a lot of this stuff is, we're still running on this, and it's very important. So, you know, it comes from ancient steam experiments to early steam pumps to atmospheric steam engines to high pressure steam to fire tube to water tube, boilers, steam turbines, electric power generations, and then automated thermal and steam plants. And that's what we're coming to today. And the bigger picture is all those things, and that, steam powered all of this stuff, the industrial revolution, railroads, manufacturing, the development of cities, growth of electric power generation, modern district heating and steam systems. So what's very, very unique about the plant that I work at, and everything. So um, when we look at steam um, distribution, or how much steam a plant can produce, I believe it was said that our plant produces 6 billion pounds of steam a year, and we're the second largest steam generator in the United States. And the first number one is New York City. So where I'm at in Indianapolis, we produce the second largest amount of steam in the United States. So that's very important. So becoming a boiler operator is a very good career path. And like I said, I was a drinking water operator. You know, I have that experience, and then I coming to this is something new for me. I just wanted to give you guys and gals a brief 40, it's like 43 minutes. It's not really brief, but just an overview of the history of steam boilers and all of those things, and why is it important, how it shapes and affects our modern day, and what's it going to do in the future. So thank you for this time to talk about it. I hope that you like, share, and subscribe my YouTube channel, H2O Hustle. Like I said, I'll have more of these shows coming out where I want to get into, maybe the next show I'll do on how to get licensed, and, what's the importance of that, and, some of the code stuff, and, all of that to, build upon it, so I can, put this out there to somebody who might be interested in being a boiler operator, or just interested in the industry. It's always good to learn these things, and to share these things, because most people don't know. They just see a plant with some smokestacks, and wonder what's going on in there, or or like you see this stuff on The Simpsons when Homer Simpson worked in a power plant. It was like, well, what is he doing? Well, now you can get a glimpse into understanding what a power plant operator or steam boiler operator does. So I just thought I'd give you that. Hope you guys and gals have a great, wonderful weekend, and I'll catch you guys again Um, catch you on the flip side. See you later.